Okay, let's take a look at a couple more from 15.3, applications of exponential functions. I had my numbering wrong on the note packet, and there was problems 1, 2, and 3, and then for some reason I skipped 4, 5, and 6. So we're picking up with problem 7 here. This one talks about population decline in a city, and the function is given that represents the decline right here after t number of years. So it asks us to find what happens after 12 years in this model. So if we put 12 in for t, we can just get this calculator problem here, and then you should be able to work your answer to 375,473. Okay, I think it says round to the nearest person. Okay, and then if they would ask you what's the population at start time, you'll kind of get familiar with this, that it's going to be this 466,000 people. But if you take a look at this, we put 0 in here, we get an exponent of 0. And remembering that if we have e to the 0, okay, e to the 0 power is equal to 1. So what I'd have is 466,000. Oops, I'm missing a 0 here. So let me get a 0 put in here. 466,000 times 1, and then that's going to give us that 466,000, okay? So at start time, there's 466,000 people, and after a decline of 12 years, becomes this, all right? Now this next problem talks about kind of a inflation, and this is the inflation model here, and you see we have our cost of a bicycle, the rate of inflation, and after a certain number of years. So we have a bicycle that costs $223. In 12 years, what would that same bicycle cost if this inflation model held true? Okay, so we put in our values here, 223, 3%, be careful to change that correctly, in 12 years, and we'll compute, and it'll be approximately $317.94 or $318, depending upon how they ask you to round that. Okay, and again, you could kind of think about what would happen at time 0. That would give you an exponent of 0 here, and this would all be 1, and so you can mess around with that a little bit. Okay, now this last problem, number 9 here, for this video, talks about the life of a battery that is left after t hours. Okay, so if we put in 50 hours for t, what we find out is, doing this equation right here, we find out that there's 0.25, okay, of the battery left. So a quarter of the battery's life is left if they ask for the fraction. Okay. And then I was again gonna just insert 0 to say at the beginning time how much of the battery is left. And if you think about this, you have 4, and then this is going to be 0, and 4 raised to the 0 is 1. So 1, kind of think about the whole battery is left at start time. Okay, so that's 3 more from 15.3.